So block of mass 20 kilograms rests on the floor of a lift. Find the reaction between the block and the floor of the lift if the lift is accelerating upwards at 5 meters per second squared. So in this situation, we're sort of homing in on something inside the lift. And that's really important that we sort of consider then what's going on with the object, okay, the forces acting on the object. So in this case, it does say this block of mass 20. So I'm actually going to draw this block, okay, and I'm going to look at its weight. So its weight is 20 its mass is 20 kilograms, so its weight will be 20 times g, okay. But it says then find the reaction between the block and the floor of the lift. Well, of course there is going to be a reaction, yeah, in terms of the fact that this block is sitting on the lift floor. If it wasn't for that lift floor, that block would just keep falling to the ground, wouldn't it? So that lift floor is actually keeping it in place. So we can then label then that force that's keeping it in place, the reaction, the normal reaction. So it's like the floor is pushing it up, okay. Of course, if that floor was too weak, the block would just fall through it, wouldn't it, and break through it and collapse and fall freely under gravity. But it's resting there because of the support of this lift. So we're told that it's accelerating upwards at 5 meters per second squared. And you might be wondering now, well, what about the lift? What about the tension in the cable? What about the mass of the lift? But we don't have to worry about that in this case because we are focusing solely on this block, okay? We are looking at the forces affecting the block. Okay, so the forces acting on the block are its weight and the reaction from this lift. And of course it shares the same acceleration as the lift, which is 5. So if I apply Newton's second law, so remember the resultant force equals mass times acceleration. So it's going upwards, so R is like the sort of bigger force, so definitely because it's accelerating upwards. So in the direction of motion, R is the driving force. Take away then the resisting force, which is the weight, 20g, and that will equal then to the mass. Now remember, it's just the object we're interested in, that's all we're focusing on, the forces acting on the block, so don't worry about the lift itself. So the block is mass is 20, and then, well, the acceleration is what we share with the lift in that sense, okay, so it's accelerating at 5 there, meters per second squared. So you do 20 times 9.8, and then of course that's 100. Okay, that will be 196, and that's 100. So then R will be 296 newtons. We've got the reaction there between the object and the floor of the lift.